UL508A Supplement SB provides guidelines for short-circuit current ratings in industrial control panels. Wire gauge plays a critical role in these calculations. The ampacity of a conductor, which is its current carrying capacity, is directly related to its gauge. A larger gauge wire has a greater cross-sectional area and can therefore carry more current safely. When performing short-circuit current rating calculations, you need to verify that the selected wire gauge can withstand the available fault current for a specific duration without exceeding its temperature rating or causing damage. Several factors influence the selection of wire gauge under UL508A Supplement SB. Firstly, the available short-circuit current at the line terminals of the control panel must be determined. This is typically provided by the utility company or can be calculated based on upstream protective devices. Secondly, the interrupting rating of the downstream overcurrent protective devices, such as fuses or circuit breakers, must be considered. The wire gauge must be sufficient to allow the protective device to clear the fault before the conductor is damaged. Thirdly, the length of the conductor run is important. Longer conductor runs result in increased voltage drop, which can affect the performance of the equipment being powered. Therefore, a larger wire gauge may be required to compensate for voltage drop, even if the ampacity requirements are met by a smaller gauge. Fourthly, the ambient temperature and the conductor insulation type affect the ampacity of the wire. Higher ambient temperatures reduce the ampacity of the conductor, while different insulation types have different temperature ratings. UL508A Supplement SB refers to NEC Table 310.16 and other relevant NEC tables for ampacity ratings of conductors based on insulation type and ambient temperature. Fifthly, the number of conductors bundled together in a raceway or cable tray also affects the ampacity of each conductor. When multiple conductors are bundled together, the heat generated by each conductor can increase the overall temperature, reducing the ampacity of each individual conductor. NEC Table 310.15. Bait 3. Provides adjustment factors for the ampacity of conductors based on the number of conductors in a raceway or cable tray. To perform the wire gauge calculation, firstly determine the available short-circuit current at the line terminals of the control panel. This information should be provided by the utility company or can be calculated based on upstream protective devices. Secondly, determine the interrupting rating of the downstream overcurrent protective devices. The interrupting rating must be sufficient to interrupt the available short-circuit current. Thirdly, select a trial wire gauge based on the ampacity requirements of the load being served. Refer to NEC Table 310.16 for ampacity ratings of conductors based on insulation type and ambient temperature. Fourthly, calculate the voltage drop for the selected wire gauge and conductor length. If the voltage drop exceeds the allowable limit, increase the wire gauge. Fifthly, verify that the selected wire gauge can withstand the available fault current for the duration of the fault. This can be done by referring to UL508A Supplement SB and other relevant standards. Sixthly, apply any necessary adjustment factors for ambient temperature and the number of conductors bundled together. If the ampacity of the conductor is reduced below the required level, increase the wire gauge. The wire gauge calculation should be documented as part of the control panel design. The documentation should include the available short-circuit current, the interrupting rating of the overcurrent protective devices, the wire gauge selected, the conductor length, the ambient temperature, the conductor insulation type, the number of conductors bundled together, and any adjustment factors applied. It's crucial to use properly rated components and follow best practices for wiring and termination. Ensure proper torque is applied to all connections to prevent overheating and potential failures. Regularly inspect and maintain control panels to identify any signs of wear or damage to the wiring. Address any issues promptly to prevent future problems. Keep detailed records of all inspections and maintenance activities. UL508A Supplement SB also addresses motor circuits within control panels. When sizing conductors for motor circuits, several additional factors must be considered. These include the motor's full load current, starting current, and duty cycle. NEC Section 430 provides detailed requirements for motor circuit conductors. For example, the conductors supplying a single motor must have an ampacity of not less than 125% of the motor's full load current rating. The overcurrent protection for the motor circuit must also be sized appropriately to protect the motor and conductors from overload and short circuit conditions. Different types of motor starters have different requirements for overcurrent protection. For example, a full voltage starter typically requires a higher interrupting rating than a reduced voltage starter. The grounding and bonding of control panels is another critical aspect of UL508A compliance. Proper grounding and bonding helps to minimize the risk of electrical shock and provides a low impedance path for fault current to return to the source. The grounding conductor must be sized appropriately to carry the available fault current. UL508A Supplement SB provides specific requirements for grounding and bonding conductors. Control panels should be inspected and tested regularly to ensure that they meet the requirements of UL508A. The inspection should include a visual examination of the wiring, components, and enclosures. The testing should include tests for insulation resistance, ground continuity, and short-circuit current rating. Any deficiencies identified during the inspection or testing should be corrected promptly. Training is essential for personnel who design, install, and maintain industrial control panels. Proper training ensures that personnel understand the requirements of UL508A and can perform their tasks safely and effectively. Training should cover topics such as wire gauge selection, overcurrent protection, grounding and bonding, and short-circuit current rating calculations. UL508 is a dynamic standard that is updated regularly to reflect changes in technology and best practices. It's important to stay up to date on the latest requirements of UL508 to ensure that control panels are designed and installed in accordance with the current standards. Subscribe to UL publications and attend industry conferences to stay informed of changes to UL508A. Using appropriate software tools can greatly simplify the process of wire gauge selection and short-circuit current rating calculations. Several software programs are available that can automate these calculations and help to ensure compliance with the UL508A. These tools can also help to optimize the design of control panels and reduce the risk of errors. Software tools often incorporate the relevant NEC tables and UL standards, making the calculation process more efficient and accurate. In summary, wire gauge is a critical factor in UL508A Supplement SB calculations. Proper wire gauge selection is essential for ensuring the safety and reliability of industrial control panels. Factors such as available short-circuit current, interrupting rating of overcurrent protective devices, conductor length, ambient temperature, conductor insulation type, and the number of conductors bundled together must be considered when selecting wire gauge. By following the guidelines in UL508A Supplement SB and using appropriate tools and training, you can ensure that your control panels meet the requirements of this important standard. This helps protect personnel and equipment from electrical hazards. Remember to always consult the latest version of UL508A and the NEC for the most up-to-date requirements. Regularly review your designs and installations to ensure ongoing compliance. Consider seeking guidance from qualified electrical engineers or consultants to ensure that your control panels meet all applicable requirements.